April 26, 1986. A shocking piece of morning news awaited the people living around Peripety, Ukraine and Belarus when they turned on their radios. They learned that the worst catastrophe in human history had just occurred. The announcement was made regarding the complete meltdown of Reactor Number 4 in Chernobyl, which resulted in a massive release of radionuclides and unfortunate loss of 31 lives. The Chernobyl nuclear reactor plant, situated on the banks of the Pripyat River, had 4 reactors capable of producing 1000 megawatt of electric power each. On the evening of April 25th, a group of engineers planned an electrical engineering experiment on the reactor number 4. Their aim was to test how long a turbine would spin and supply power to the main circulating pumps in case of a loss of main electrical power. However, due to unsafe control rod design and a positive void coefficient in the reactor, a disastrous chain of events unfolded. Hi, I am Hilal Alam from ALZEBRA. Let us see what triggered the worst catastrophe ever happened in our history. The RBMK-1000 reactor used in Chernobyl was a Soviet-designed graphite-moderated pressure tube type reactor. The fuel, made of slightly enriched uranium dioxide, was surrounded by zirconium alloy clad pressure tubes through which cooling water flowed. In this reactor, water pumped into the bottom of the fuel channel would boil as it progressed upward, producing steam to drive the turbines. The reactor had a system where 2 loops directly supplied steam to the turbines. There are 4 main coolant circulating pumps, one of which is always on standby. The moderator, the function of which is to slow down neutrons to make them more efficient in producing fission in the fuel, is graphite surrounding the pressure tubes. The reactivity of the reactor was controlled by rising or lowering 211 control rods that absorb neutrons and reduce the fusion rate. The extensions of the fuel channel penetrate the lower plate and the cover plate of the core and are welded to each. Water was pumped into the bottom of the fuel channels, and as it moved up the pressure tubes, it would boil, producing steam that would power 2 500 megawatt electric turbines. The water served as both a coolant and a source of steam for the turbines. The RBMK reactor had a characteristics known as positive void coefficient, where an increase in steam bubbles or voids led to an increase in core reactivity. The increasing steam production in the fuel channel increased the fusion reaction. On contrary, the neutron would be absorbed by denser water. Hence, the maintenance of water-steam ratio is crucial. Their aim was to test how long a turbine would spin and supply power to the main circulating pumps in case of a loss of main electrical power. On April 25, during the test, the crew slowed down the turbine, causing excessive cold water and more neutron absorption. Power production decreased further, prompting them to raise the control rods. This led to increased radioactivity. The interaction between the hot fuel and cooling water caused fuel fragmentation, rapid steam production, and rise in pressure. Intense steam generation occurred throughout the core, causing a steam explosion and releasing fission products into the atmosphere. The overpressure caused the reactor's cover plate to become partially detached, rupturing fuel channel and jamming the control rods. A second explosion followed, likely due to hydrogen production from zirconium steam reaction. Due to the reactor's design, even damage to a few fuel assemblies could result in the destruction of the reactor. The accident released large quantities of radioactive substance into the environment, causing the largest uncontrolled radioactive release in any civilian operation. The short-lived iodine-131 and long-lived cesium-137 radionuclides delivered substantial radiation doses to the public. It led to significant social and economic disruption for population in Belarus, Russia, and Ukraine. Approximately 3,100 square kilometers of land was affected, causing 60 lives in a decade, with Belarus being the most severely impacted. Thus, a test intended to evaluate preventive measures resulted in an unimaginable catastrophe, making it as the worst accident in human history. With this, I sign off. We'll meet in the next video. Thank you very much.